So in an electric circuit, a device called rheostat is often used to change the resistance of the circuit. Take a nichrome wire, this is nichrome wire, and a 10-watt bulb, and an ammeter range, this is ammeter range 0 to 5 amps, a plug key, and some connecting wires. These are all the connecting wires. Set up the circuit by connecting 4 dry cells. So 4 dry cells they have connected, each having 1.5 volt into 4 in series with the ammeter leaving a gap XY. This is the gap. Now what you have to do? Complete the circuit by connecting the nichrome wire in the gap. Here what you have to do? You put the nichrome wire in this gap and note down the ammeter reading. Ammeter reading, that means current you note down. Take out the key from the plug. Note, always take out the key from the plug after measuring the current through the circuit. Now replace the nichrome wire with the torch bulb. Here what you have to do? Take this nichrome wire from here. Again you put 10-watt bulb. Okay. Now again measure the ammeter reading. That means I. Now repeat the above step with the 10-watt bulb in the gap. Are the ammeter readings one time I you got with the nichrome wire? Correct na? Again one time I you got with 10-watt bulb. All these are same? No, they are not same. That means, and again you may repeat this activity by keeping any other component in the gap. Observe the ammeter reading. Analyze the observations. So in this activity we observed the current is different from the different components because certain components often has easy path for the flow of electric current while the others resist the electrons to flow. So motion of electrons through a conductor is retarded by its resistance. Components of the given size that the offers a lower resistance is a good conductor. If the wire having low resistance, we are having a one resistance which is having low resistance, then this is a good conductor. A conductor having a some appreciable resistance is called a resistor. So this resistor is having more resistance, then this is called a resistor. A component of a identical size that offers a higher resistance is a poor conductor. If the resistance is still more, that is called poor conductor. An insulator of the same size offers a higher resistance. Insulators are having high resistances. Okay. So here factors on which the resistance of a conductor depends on. So this is the resistance we know. Okay. So on what factors this resistance is depends while current is flowing. See, here they have given one activity 12.3. Complete the electric circuit consisting of a cell. See, this is a cell and a ammeter. See, this is the ammeter. A nichrome wire. So these are all the nichrome wires. and a plug key. Okay. Now plug the key, note the current ammeter. You put, see, just I will explain. He has taken 4 wires, 4 resistances. In that, one is nichrome. So label is length 1L. So second one is same nichrome wire. It is a twice of number 1. That is length is double. And third, he has taken same nichrome wire with more dia. Fourth one is different metallic resistance. Okay. Now you put number 1. This is the number 1 nichrome wire. This is one. Plug the key. Note down the ammeter reading. So this one, you note down the first ammeter reading. Replace the nichrome wire by another nichrome wire, same thickness but twice the length. This is number 2. Now you connect number 2 here. Okay. And note down the ammeter reading. This is a second reading. Second ammeter reading. Now replace the wire by a thicker nichrome wire. Now this also you remove. Put the number 3 in place of 2. So same length. Okay, same length. Number 1 we have taken that. So a thicker wire has a longer cross sectional area. That means dia is more. Again note down the current in ammeter. This is the third reading. Okay. So instead of taking a nichrome wire, connect a copper wire. So I told you different metallic wire. Now you put, he has mentioned copper wire. Okay. Copper wire in the circuit. Let the wire be a same length. Length is same. And the same cross section as that of the first nichrome. First nichrome we have taken same dia and length. So note the value. This is the value of current. Again ammeter read. This is the fourth ammeter reading. Okay. So note the difference in the current in all the cases. Just you see what is the difference. Does the current depends on the length of the conductor? Okay. Does the current depends on area of the cross section? Yes. So it is observed that ammeter reading decreases to 1/2 when the length of the wire is doubled. So the ammeter reading is increased when the thickness of the wire of the same material and of the same length is used in the circuit. So a change in ammeter reading is observed when a wire of different material of the same length and the same area cross section is used. So if you apply the Ohm's law for this resistance, you will get, so resistance of the conductor depends on its length and cross sectional area A and the nature of the material we have used. So resistance of uniform metallic conductor is directly proportional to length. So he is telling resistance is directly proportional to length and inversely proportional to, and resistance is inversely proportional to A. If you club this, you will get R is directly proportional to L and inversely proportional to A. So if you remove this proportionality constant, you will get a R is equal to rho into L by A. This is called rho. RHO, rho. Okay, this is called proportionality constant, where rho is a constant of proportionality and it is called the electrical resistivity of the material. So we have considered now one resistance. So it is opposing to flow current. That is called resistivity, electrical resistivity of the material of the conductor. The SI unit of resistivity is ohm meter. Ohm meter. So it is characteristic property of the material. So all materials having this property depending on their nature. The metals and alloys have very low resistivity. See, metals and alloys have very low resistivity in the range of 10 to the power of minus 8 ohm meter and 10 to the power of minus 6 ohm meter. So they are good conductors of electricity. The metals who is having very low resistivity are called good conductors. This they may ask in examination. So insulators like rubber and glass have resistivity of order of 10 to the power of 12 to 10 to the power of 17 ohm meter. Both resistance and resistive of the material are vary with temperature. So it depends on temperature also. Okay. The resistivity of an alloy is generally higher than that of its constituent metals. Okay, alloy means we are using more than 2 elements, mixing up more than 2 elements. So compared to these individual elements, these alloys are generally higher resistivity. Okay. So alloys do not oxidize or burn readily with high temperatures. For this reason, they are commonly used in the electrical heating devices like iron and toasters. Why we are using alloy for electric iron means electric iron coil means, see, resistance we are using is, see, clearly as mentioned, the resistivity of an alloy is generally higher than its constituent metals. So alloys do not oxidize readily with high temperatures. Okay. So that's why we are using the alloys in the electric iron and toasters, etc. And also tungsten is used in almost exclusively for filaments of electric bulbs. So electric bulb, if you see na, there they have one filament will be there. So that is made up of tungsten. Whereas the copper and aluminum are generally used for electrical transmission of lines.